This model, we are generating equivalent fractions using models. This model shows one whole, and we divide it into two equal parts. There's 1/2 and 2/2. That equals one whole. So, already off the bat, I can write a statement that says 2/2 is equal to one whole. That means they are the same. There's no more on this side than there is at the top. There's nothing less than this whole as well. They are equivalent. They are equal to each other. So an equivalent fraction can be drawn with a fraction strip. A fraction strip, I'll show you here in a second, is nothing more than a rectangle. Okay, so to generate an equivalent fraction that is equal to 1/2, that's our goal, we can draw a fraction strip. Here's how to do it. So you take a look at your whole, and then you're going to divide that into two equal pieces like we saw on the other page. So I'm just going to divide this into two equal pieces. I'm going to shade one of them so that this model shows 1/2. Okay, so now my model shows 1/2. To generate an equivalent fraction, I need to see how many different ways I can divide that model into pieces and still keep my 1/2 pieces. So I'm not adding anything else, I'm just leaving this one portion shaded. So let's say I want to divide it into two equal pieces. There's section 1 or part 1 and part 2. 1 and 2. If you notice, I've generated the same looking fraction up top as well as on the bottom. That's going to come in handy when we're multiplying a little bit later. But now if you notice, I have more pieces. The more you divide a fraction, the more pieces you will have, and the smaller those pieces are going to become. So I now have two shaded pieces out of 1, 2, 3, and 4. Therefore, 1/2 is also equal to 2/4. I can do the same down here. I can think of a different way to divide this 1/2 to create an equivalent fraction. So let's say the next time I wanted to divide these into 4 equal pieces. So I will start here. Say I have 2 equal pieces. I'm going to divide them one more time. Notice I haven't added anything to my shaded area and I have not taken anything away. So now, out of my entire whole, I have 1, 2, 3, 4, 5, 6, 7, 8. So now I have successfully divided this whole into 1/8 pieces. So that will be my denominator. That's how many pieces are divided in the whole. And now I need to look at my shaded pieces. 1, 2, 3, 4. There are 4 pieces that are shaded, and that is my numerator. Therefore, 4/8 is also equivalent to 1/2. Okay, let's try another. I'm going to go ahead and shade in 1/2 just as I started. And I'm going to divide it, let's say, let's divide it into thirds. So I'm going to start with my initial fraction up top, and then I'll divide it one more time. So I've got 3 of the same looking fraction. If I were to break these fraction strips apart, they would look identical to each other. They would be equivalent. I haven't taken anything away still. Haven't added any extra bars. They are equivalent. So I'm looking here. I've now got 1, 2, 3, 4, 5, and 6. That is my denominator. That tells me how many pieces the whole have been divided into and how many are shaded. 1, 2, 3. 3 out of those 6 were shaded. Therefore, 1/2 is equivalent to 3/6. So far I found 1, 2, and 3 equivalent fractions. So I'll write those down. Let's see. 1/2 is equal to 2/4. Just going to make a little list. 3/6 and 4/8. Okay, I'll try one more. Shaded my 1/2 to start with because this is our benchmark. This is what we're comparing all the other fractions to. And this time I will divide in a different way. Let's see. This is similar to that fraction that I just made over there. Okay, so now if you can look, I've got more pieces in my whole. Forgive the wonky line, it should be as straight as it possibly can. But that's the thing with fraction strips. Get it very close, or as close to as possible, and be very intentional with your lines. So this fraction that is shaded will be equivalent to 1/2 because this is the portion I'm looking at. I just need to count up my entire pieces and see. So the whole number of all of these pieces is I've got 1, 2, 3, 4 groups of 4. So that's going to be 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. That's where I got my 16ths from. If you notice the shaded portion, I've got 1, 2, 3, 4, 5, 6, 7, 8. 8/16 is also equivalent to 1/2. The next way that we are going to generate some equivalent fractions is by using multiplication. So the big thing to remember is whatever you do to the numerator, you do to the denominator. That'll definitely make you make it easier to make equal groups, because when you multiply, you make equal groups. So for example, if I am starting off with 2 items and I multiply that by 2, then I make 2 equal groups of 2. So there's my first group, and there's my second group. So 2 times 2 equals 4, making 2 equal groups. We're going to do the same thing with our fraction strips. We are going to be making 2 equal groups of the same fraction. They'll need to look the same, they'll need to be equivalent. So there's set 1 and set 2. But again, whatever you do to the top in your fraction, your numerator, you have to do to the bottom. So in this case, 1/2, and I want to make 2 equal groups of 1/2, I'm going to multiply that by 2. Again, the top multiplied by 2, 1 times 2 is 2, and then I'll multiply the bottom by 2. 2 times 2 is 4. Therefore, I've just generated another equivalent fraction only using multiplication. I didn't use my model for this. This is just the multiplication method. So this statement would be 1/2 is equivalent to 2/4. I could also say 2/4 is equivalent to 1/2. Okay. I'll have my model here just as in the background. There's my whole, and they are divided into 2 halves. So there is 1 half right here, and here's another half, 2 halves. 2 halves equals 1 whole. So I need to divide this into 2 equal pieces. Again, remember we want to make the diagram the same. This is my first group. There's 1. And this is my second group. This is where the numbers that you're multiplying by is coming from. Okay, so I'm going to take 1 half and I'm going to multiply it by 2. Whatever you do to the top, you must do to the bottom, so I'm going to multiply that by 2. If you notice, my shaded area, I've got 1 half and another 1 half. And here I've got 1, 2, 3, 4 pieces. So 1 and 2, 1 times 2 is 2. That represents just the shaded area. And then the 4 represents all of the pieces that you have from your model. 2 times 2 is 4. Another equivalent, if I wanted to make 3 equal groups divided into thirds, I would do the same process, still taking my 1 half, and now since I have 1, 2, 3 equal groups, I'm going to multiply that by 3 to get another equivalent fraction. When you use multiplication, you can really pick any number to divide your fraction into and you will generate an equivalent fraction. So the equivalent for 1 half, when I multiply this by 3, is 3/6. If you need to pause and work that out, go ahead and pause. So I'm going to leave the models up there, but I'm going to strictly use my multiplication. Again, we know that this is 1 half, and I want to generate as many fractions using multiplication only to show what is equivalent to 1 half. So I've done 1 half times 2, I've done 1 half times 3. Let's pick another number like 9. Whatever you do to the top, multiplies wise, you're going to do to the bottom. So 1 times 9 is 9. 2 times 9 is 18. Therefore 9/18 is equivalent to 1 half. Okay? I could pick an outrageous number like 100. It's not too outrageous, but it'll still work. Remember, whatever you do to the top, you do to the bottom. 1 times 100. 2 times 100. So an equivalent fraction for 1 half is also 100 200ths. Also, just a hint, these are going to be your benchmarks. So if you're looking at a number line, no matter where it starts, the halfway point in between 2 whole numbers, so even if I start at 1 here and go here, this is going to be your equivalent in the middle, half of that. It should look much like your model. So if this was my number line, here's my first point, here's my second point. Anything that's equivalent to half will fall smack dab in the middle of that number line. Your turn. If you've got a piece of paper handy, go ahead and create a model just to have it up there, just to look. This is a model that shows 3/4. This is 1/4, 2/4, 3/4. And then this, of course, this would be 4/4 if we shaded that in, but this is the model. For this model, I'll go ahead and let you calculate what the model is, and I'll write it off to the side. I'll give you a second. So, what I'm going to do is I'm going to set up a problem down here for you, and then you try it out. 3/4, 4/9. I want to multiply this by different set of numbers. Let's go ahead and give 2 a try, and let's see what you come up with to find an equivalent fraction there. And let's try, oh, I don't know, fifths, or 5. To generate your equivalent fraction. You can go ahead and pause the video now to do your calculations and meet me back here when you're ready. Chance to do your calculations. So now, in making an equivalent fraction, I'm multiplying 3 times 2, and that is 6. 4 times 2 is 8. So 3/4 is equivalent to 6/8. Okay, let's go over here. 4 times 5 is 20. 9 times 5 is 45. So the equivalent fractions for 4/9 is 20/45. So I would write it as this. 4/9 is equal to 20/45. 3/4 is equal to 6/8. Okay, if you have any big questions, make sure to ask your teacher. I hope you give a chance to find some other equivalent fractions. Any number will work, but you must remember, whatever you do to the top of the fraction to your numerator, you must do to the denominator. So numerators up top, denominators at the bottom. Alright, thanks for watching. Give it a try. Again, if you get stuck, don't be afraid to ask your teacher.